Alrighty, so now let's finish up example 2 and example 3. So example 2 for this, so 2.2, we are given f of x equals x squared minus 16x plus 64, and we're going to find the following three things. It's not asking us for vertex form, but what I want to do is, just so you guys can see more examples, I'll go ahead and show you guys the vertex form, right? So I'll just say pretty, okay? Not even required, but good to know, good to see, right? So I'm going to find the vertex form, okay? So the first thing that we want to do is we want to factor out, we want to make sure that the coefficient of my leading term is 1. Luckily, it's already 1, okay? So I'm just going to put parentheses around them just to show that these are the two terms I am working with. Okay, and then now what I'm going to do is I'm going to complete the square. So I want to add and subtract a number. And remember that number is b over 2 quantity squared. In our case, b is negative 16. So this is going to be negative 16 over 2 quantity squared. So this is negative 8 quantity squared. And this is 64. All right, so I'm going to add 64. Now I'm going to subtract 64. Okay, plus 64 over here. Okay, remember I want to kick out, so I want to keep the perfect square trinomial, and I want to kick out that extra term. And this, so I'm going to distribute, okay, but it's just a 1. Okay, so if I multiply that, then I'm just left with x squared minus 16x plus 64 minus 64 plus 64. Okay, then I'm just left with x minus 8 quantity squared plus 0, which is just x minus 8 quantity squared. Okay, so this is my vertex form. Alright, so remember this number right here, this minus 8, it is the b over 2, so this negative 8 right here, they are the same. So maybe I should put different colors. Okay, so these two numbers are the same. Right? So now let's find the x-intercepts. Okay. I'm just going to use the given function above. The reason why is because that's the function we're working with. Okay, so because assuming that we're not going to do that. Okay, so remember, for an x-intercept, you want to let f of x equal to 0. Okay, so then I get 0 is equal to x squared minus 16x plus 64. Okay, then this is x minus 8 quantity squared. Okay, so then I get 0 is equal to x plus minus 8. Then I get x is equal to 8. Okay, so remember we let f of x equal 0 and we let x equal 8. So if it would be x f of x. Okay, this is the same as saying xy. Right, but so then my x-intercept in point form would be 8, 0. Because remember we let f of x equal 0, and then we got x to be 8. Right. So now let's use the definition we learned about discriminants. Okay, and let's just check to make sure did we do this correctly. Okay. So we have a is equal to 1, b is equal to negative 16, and c is equal to 64. Right? So then I get b squared minus 4ac. Okay, then I get 16 squared, so negative 16 quantity squared minus 4, 1, and then 64. Okay. Is that? Okay, so negative 16 quantity squared, that's 256. Okay, and then 64 times 4. I'm pretty, so, okay, let's check it. Pretty sure that is also 256. Yep, 256. Okay, and I get 0. And what does it mean when our discriminant is equal to 0? It means 1 x-intercept. Okay, so it was correct because we were correct because we just got 1 x-intercept. Okay, so very good. Now what we're going to do is we're going to So again, but if you decided to use a vertex form for this one, all you had to do, so you would have just been left with 0, and then x minus 8 squared, and then you would have gotten x is equal to 8. Okay, after you do the, after all the work, you'll still get the same. Okay. For B, okay, we want to find the vertex. So assuming we don't have the vertex form, okay, remember our vertex, we can find it by using this. Okay, we have negative b over 2a, f of negative b over 2a. Right? So, yeah, we have everything right there. So negative b over 2a. Then I get negative 16 over 2 times 1. Then I get 16 over 2, and I get 8. Right? And then now to find f of negative b over 2a, this is going to be f of 8. Right? F of 8 will be 8 squared minus 16 times 8 plus 64. This is 64 minus 128 plus 64. Okay. 64 plus 64, that's also 128, so this is 0. So our vertex is 8, 0. Right? And that makes sense, right? Because when you have one vertex, okay, maybe I should have added a picture. So kind of sidetracking here, when you have no x-intercepts, that just means like you have a graph looks like this, okay, or it looks like this, okay. If you have one x-intercept, then our graph either looks like this, where it touches right here. So usually the x-intercept is your vertex. And then again, if you have two, then it would just look like this, or it could look like this. Okay. So yeah, so this kind of holds since we have one x-intercept. Normally it is the vertex. Okay, so we can actually check this work, okay, because we can look up here in the vertex form, and so we have x minus 8 quantity squared plus nothing, so that's our HK, so our HK is 8, 0, so that holds as well. Right. So now we're going to do the final part, which is C, and it says find the function's minimum or maximum value and where it occurs. So first we want to find, is this a minimum or a maximum? In order to do that, we have to look at our A. In our case, our A is equal to 1. Okay, 1 is greater than 0. Since it's greater than 0, what does that mean? That means our graph is going to point upwards. Okay, since it's not negative, there is no reflection. All right. Since this points upwards, okay, so you can even just draw yourself a little sketch. It goes this way. And what is the vertex? It is the minimum, okay? So, because remember, either the vertex is the minimum or the maximum point. So now we know that it's a minimum. So it's a minimum, and we're going to find the value. So the minimum value is, and remember it's our K, so it is 0 at x is equal to 8. Okay, you just got to use your vertex because remember this is HK. All right, so our minimum value is 0. It is this y component, and then at x is equal to 8. Right, so again, and then this x equals to 8. That is also our axis of symmetry. Right, and that's essentially what you're finding here. Like the negative b over 2a, that is the axis of symmetry. Okay, because remember axis of symmetry is x is equal to h, right? It is that first component of your vertex. Okay, so that was 2.2. Now let's do another example. Okay, so we're going to do 2.3. 2.3, we are given f of x is equal to negative x squared minus or plus 4x minus 5. again, I'm going to do the pre, and I'm going to find the vertex form. Okay, so again, remember we just want to focus on these two. Okay, and we're going to factor any number out that, so our leading coefficient is 1 inside the parentheses. So I'm going to factor out a -1, and I'm left with x squared minus 4x minus 5. If I distribute this -1 back in, I will get above. Okay, so now we want to find a perfect square trinomial. Okay, so again, we want to look at b over 2 quantity squared, and our b is -4. So this is equal to -4 over 2 squared. This is -2 squared. So this is 4. Okay, so x squared minus 4x. I'm going to do plus 4 minus 4 minus 5. Again, okay, I just want the perfect square trinomial. I don't need the extra baggage. So what I'm going to do is I'm going to kick that guy out. And so I want to kick this guy out. In order to do that, I have to distribute it out of my parentheses. Okay, so I'm left with negative and then negative x, or so x squared minus 4x plus 4. And then -1 times -4, that's positive 4, and then minus 5. Then this is a perfect square trinomial, so this is x minus 2 quantity squared, and then plus 4 minus 5 is -1. Okay, so this is my vertex form. Okay, so let's do A. A, we want to find the x-intercepts. So so we want to let f of x equal 0. When I do that, I get 0 is equal to -x squared plus 4x minus 5. Right. So okay. Sorry. Okay. So I'm going to factor out a -1 when I get that, and then x squared minus 4x plus 5. Okay, so I get 0, and then I get x squared minus 4x plus 5. Now I want to find two numbers that multiply to be 5, positive 5, and add to be -4. Okay. But as you can see, so 5, it is a prime number, so I only have one option. I have 1 and 5. Okay, but since it's plus 5, it can either be plus 1 plus 5 or -1 minus 5. Either way, I would get plus 6 when I add or minus 6 when I add. Okay, so it doesn't factor out nicely. But before we continue, okay, before even wasting our time on the quadratic formula, okay, or completing the square, assuming that we did not find the vertex form, okay, you can just find the discriminant first. Okay, so this is -4 quantity squared minus 4, 1, and 5. This is 16 minus 20 is -4, less than 0, so no x-intercept. Okay, so yeah, even just by using this discriminant, you don't even need to show to me that there's any i's. Okay, you just need to find a discriminant. If it's negative, then you can just automatically say no x-intercept. All right. Again, if you use this, if you did use the vertex form, okay, if I have f of x is equal to negative and then x minus 2 quantity squared minus 1, and let f of x equal 0, then you'll get 0 is equal to negative x minus 2 quantity squared minus 1. Okay, you'll be left with -1 is equal to x minus 2 quantity squared. And this will be plus or minus the square root of negative 1 is equal to x minus 2. Again, you can't have a square root under a negative number under the square root, so no x intercept. Right? So that was just another way. If you made your if you made your function into vertex form. Right? So now what we're going to do is we're going to find the coordinates of the of our vertex. So I'm just going to look ahead, okay? So using my vertex form, I can see that my vertex is 2, negative 1. Okay, positive 2, negative 1. Okay, so now let's prove it by just using the vertex to be negative b over 2a, f of negative b over 2a. Okay? So, negative b over 2a, we know that to be, so negative 4 over 2 times negative 1. So this is negative 4 over negative 2, and this is positive 2. Okay? And then f of negative b over 2a is f of 2. Okay, and wherever I'm going to look at my original function, and wherever I see an x, I'm going to plug in a 2. So I have negative and then 2 squared plus 4 times 2 minus 5. Okay, so I have negative 4 plus 8 minus 5. This is negative 1. Right, so then vertex is equal to 2, negative 1. Right, and that fits with our vertex form. So very nice. Lastly, we now want to find the function's minimum or maximum value and where it occurs of the following quadratic functions. So first of all, we need to determine, is this a minimum or maximum value? So I'm going to look at my a. My a is negative 1. What does that mean? So this is less than 0. So since it's a negative, it means that I had a reflection. Okay, so it's a reflection across the x-axis. So this is going to point upwards. Okay, so it's going to look like this. So my vertex is a maximum. Okay, so now we can answer a question. Our maximum value is, remember, it is always your k. So my maximum value is negative 1. And then the location where it occurs is at x equals 2. Okay, it is my h. Okay, where it occurs, it is usually the axis of symmetry. Right? So that is it for example 2. The last example I want to do is I want to graph the following parabola. Okay. So again, I'm going to show you 2 ways, but I'm just going to graph it once. But I just want to show you that you can still get the same. Okay. So example 3, I'm given y is equal to negative 3x squared plus 12x minus 9. The first way, okay, and I do not recommend this until you are comfortable finding the vertex form, okay, because you need practice. But what we can do is first we can find the vertex, okay. So I guess you can always... no, I'm just going to do it separately. So negative b over 2a. This is negative 12 over 2 times negative 3. This is negative 12 over negative 6. And this is 2. Right? And then so f of negative b over 2a, that is equal to f of 2. Okay, so this is negative 3, 2 squared, plus 12 times 2 minus 9. So this is negative 3 times 4. Plus 24 minus 9. This is negative 12 plus 24 minus 9. So 24 minus 12 is 12. 12 minus 9 is 3. Okay, so my vertex is 2, 3. Okay. So what are we going to do with this? So this is just assuming that we want to plug in 5 points. So remember, in order to plug in the 5 points, you need to know what the vertex is first. So if we have my x, y, okay, we know this would be 2, 3, and you want to pick 2 numbers to the left and 2 numbers to the right. So you can pick 0, 1, and then 3, 4. Okay, again, I know you all are more than capable of plugging in these x values into your function to find your y values. Okay, so I'm not going to continue on with this. Another way to do this is to find the vertex form and then use transformations. And so I will show you guys how to do that. Okay. So we have y is equal to negative 3x squared plus 12x plus 9. Okay, I want you guys to be really, really careful here because, not plus 9, minus 9. Okay, first of all, make sure you write the problem down correctly. That's important. But always make sure you're only looking at the x terms, the terms that have x in it. Okay, because it's really easy. You see that all three of these have a 3 in common, and you're going to want to factor it out for all 3. Don't do that. Okay, just focus on the x terms. So just focus on this. Okay, and when we do that, so remember we want the coefficient of this to be 1. So I'm just going to factor out a negative 3, and then I'm left with x squared minus 4x, and then minus 9. If I distribute this back in, we get the top. Now, okay, I want to find a perfect square trinomial. How am I going to do that? I'm going to use this b over 2 quantity squared. B in this case is negative 4, so this is negative 4 over 2 quantity squared. So this is negative 2 quantity squared, so this is 4. So I'm going to add 4, now I'm going to subtract 4. Again, I want only the perfect square trinomial, okay, so we got to get rid of the extra baggage. So I'm going to take this negative 3, and I'm going to distribute it into my negative 4. So I have negative 3, and then x squared minus 4x plus 4, and I have negative 3 times negative 4, that is positive 12 minus 9. Okay. So now I'm going to do 2 steps here. I'm going to factor this perfect square trinomial. This is x minus 2 quantity squared, and 12 minus 9, that is plus 3. Okay, so this is my equation in vertex form. Okay, and again, the vertex, okay, is equal to 2, 3. And as you see, it matches up here. Okay. So now what I'm going to do the transformations. Okay, so remember we need the parent table. So remember these quadratic equations, it has a parent function, so I'll just call it p of x is equal to x squared. I strip it from all its frills, and I'm just left with x squared. Okay, so this is negative 2, negative 1, 1, 2, and then this 4, 1, 0, 1, 4. Okay, so now what I'm going to do is I'm going to use the transformations. I know a is negative 3, I know my h is 2, and my k is 3. Okay, so I'm going to do x plus 2, because remember this would be x plus h, y. This is x and then y plus k, and then this is x, a, y. And then if we're doing it in order, this would be 1, 2, and 3. Okay, but I'm just going to do it all at once. Right? But again, I just wanted to say, and this is why the horizontal, like the stretches and shrinking went first, because multiplying came before this. Okay, again, if you did the horizontal shrinking or stretching, it would be a number like a and then times the quantity x plus 2, for example. Okay, but luckily we never have to worry about this in vertex form. Right, so this is going to be negative 3y plus 3. Okay, so this is 0, 1, 2, 3, 4, and my y. So negative 12 plus 3, that's negative 9. This is 0, 3, 0, negative 9. Okay. And then I'm going to use those points to graph. Or, one second, I gotta look for my graph. Oh, right here. Okay, so let's plot the points. I have 0, negative 9. Wait. Sorry, geez. 0, negative 9. 1, 0. 2, 3. 3, 0. And 4, negative 9. Oops. Okay, let me try that again. Okay. So yeah, this is how you graph the parabola. Another way, I won't go over it, is kind of using what we did here. So determining whether the parabola opens upward or downward. Okay, since A was negative 3, it's negative, so it goes downward. Identify the vertex, and then you can find the x and y intercepts. Okay, and then you can use that to sketch the function. So as you could, this one would have been a little easier to see because as you can see, these were the x-intercepts, and then our y-intercept was right here. Okay, and then we just know, so this one we wouldn't have seen, right, because this is our vertex, so this one was our vertex. But this 4, negative 9, it would just been, we would have plotted just knowing the properties of a parabola and knowing that it is symmetrical, okay, along the vertex. So then the next one had to be 4, negative 9. All right. So, but that is it, and I will talk to you all on Friday. Bye.